we now discuss the solution of a problem from the section Permutations and Combinations. This question is on the concept of counting. This question has appeared in the joint entrance examination main held on 26th June 2022 in the second shift. The given question is the total number of three-digit numbers whose greatest common divisor with 36 is 2 is, we have to find the total number of three-digit numbers whose greatest common divisor with 36 is 2. We now discuss the solution of the problem in detail. We first note down the prime factorization of 36. 36 is equal to 2 square into 3 square. Agreed. Let S be the set of all three-digit numbers whose GCD with 36 is 2. Then S is equal to the set of all n such that the GCD of n with 36 is 2 and n is a three-digit number. So that is what is precisely S you have to find. Number of elements in S you have to find. And this will imply S is the set of all three-digit even numbers. Why even? Because the n comma 36 is 2. That means this number n must basically an even number. So because the GCD is 2, S is the set of all three-digit even numbers and which are not multiples of 2 square. Why? Why? If they are multiples of 2 square, the GCD will increase, will be more than 2. And not multiples of 3, not multiples of 3. Again, the same reason. If they are multiples of 3, the GCD will increase. So therefore, S is the set of all three-digit even number which are not multiples of 2 square and not multiples of 3. So let capital A be the set of all three-digit even numbers. Agreed. Let B be the set of all those x belongs to A, all those three-digit even numbers, where x is a multiple of 2 square. So, x belongs to A and x is a multiple of 2 square. So, the multiples of 2 squares of three-digit even numbers will be there in B. Let C is equal to the set of all x belongs to A, x is a multiple of 3. Therefore, it consists of all those three-digit even numbers which are multiples of 3. Note that B is contained in A, obviously, because the elements of B are elements of A with a property. So B is contained in A, so also C is contained in A. And further note down, C contains multiples of 3 square also. So if a number is a multiple of 3 square, it is definitely a multiple of 3. So if you take the set of all multiples of 3, it includes the multiples of 3 square also. Therefore, there is no need of taking another set. Now, S is equal to A intersection, that means the set of all those three-digit even numbers, that is A, which are not multiples of 2 square. B is the set of all multiples of 2 square. Not multiples of 2 square will be B complement and not multiples of 3 C complement. And that means it will be A, all those three-digit even numbers with this property, not multiples of 2 square, is in B complement, and not multiples of 3 will be C complement. Now see, now B complement intersection C complement can be written as B union C complement. This is De Morgan's law. We are using De Morgan's law. Now A intersection B union C prime is equal to A minus B union C. Yes. A minus B union C. Now what do we want? We want the number of elements in S. So n of S will be n of A minus B union C. That means n of A minus, U is a formula, n of A intersection B union C. Now suppose if you want n of A minus B, then n of A minus n of A intersection B. So n of A minus B union C is equal to n of A minus n of A intersection B union C. A intersection B union C is B union C only because B is contained in C is contained in A and B union C is contained in A. Therefore, A intersection B union C is just B union C only. Therefore, n of A minus n of B union C, and that will be equal to n of A minus, in brackets, n of B union C is, use the principle of inclusion and exclusion, n of B plus n of C minus n of B intersection C. That is the principle of counting that you are using, and it comes under counting. So take out the minus. So it will be n of A minus n of B minus n of C plus n of B intersection C. Thus n of C, n of S has n of A minus n of B minus n of C plus n of B intersection C. What are these n of A, n of B, n of C, and all that? We will compute, we will find out what are these numbers. We continue. We have that formula, what we have derived for our situation. Now A is equal to the set of 3-digit even numbers. What are the 3-digit even numbers? Which will start with 100 and even 102, 104, 106, so on and so forth, ends with 998. How many of these? So they are in AP with first term 100, common difference 2, and the last one is 998. So that is 100 plus n minus 1 into 2 is equal to 998. Solve for n, we will get 450. So n of A is 450. Now B is the set of all x belongs to A. That means all 3-digit even numbers. In that, x is a multiple of 2 square. So even and multiples of 2 square. It will start with 104, 108, 112, so on and so forth. Ends with 996. How many of these? Again, you try the AP with first term 104, common difference 4, the last term 996. That will give you 104 plus 9 minus 1 into 4 is equal to 996. On solving, you will get n is equal to 225. Therefore, n of B is 225. C is the set of all x belongs to A. X is a multiple of 3. So that is the set of 3-digit even numbers which are divisible by 6. Why? So x belongs to A means it is a even number, 3-digit even number, and x is a multiple of 3. So even number and a multiple of 3 means this is a 3-digit even number which is divisible by 6 or a multiple of 6. So that means it will start with 1 and 2. Yes, 1 and 2 is divisible by 6. That is the first 3-digit number. 108, yes, plus 6, 114, ends with 996. And use the same one, the same formula, what you have, then you will get the number of elements will be 150. Now what is B intersection C? Because we want B intersection C here. It is a set of all x belongs to A. X is a multiple of 2 square and x is a multiple of 3. So it is a multiple of 2 and multiple of 2 square and n multiple of 3. That means the set of all 3-digit even numbers which are divisible by 12. So that means 2 square and 3. 2 square, 3. The GCD is 12. So the set of 3-digit even numbers which are divisible by 12, this starts with 108, yes, 120 plus, and the next one is plus 12, 132. The last one is 996. And use this same technique as above. They are in AP with first term 108, common difference 12, yes, and the last term is 996. The number of terms will be 75. So we got all these. Now we are ready to compute n of s. N of s is equal to n of a minus n of b minus n of c plus n of b intersection c. N of a 450, n of b 225, n of c 150 plus n of b intersection c, that is 75. This is 75. So now simplify, you will get this is 150. Thus we got the number of 3-digit numbers whose GCD with 36 is 2. We got the answer as 150. So that is the detailed discussion of the solution of the problem, which is based on the concepts of counting from the section Permutations and Combinations. I am sure that you have understood the solution of this problem, and I wish you all the best. Thank you.